All right, so we're gonna do more questions here. So this is part 3, I believe. So a ball is thrown vertically upwards from the ground. The ball rises to a height of 8 meters. So let me just draw out our scenario. So we have the ground, and let's say I am here, this is me, and I'm throwing up a ball. So let's say I'm a flat person, right? I'm on the ground. I'm a flat person. I am the ground, something like that. And I throw a ball upwards. And the height of the ball goes up 8 meters. All right. So that is what we have. So it goes up 8 meters and then falls and bounces. And after each bounce, so after, let's say it hits the ground and bounces up, it goes up to 3/4 of its original height. So after the first bounce, it's going to go up 8 times 3/4 of its original height. All right. So before any bounces, it's up 8 meters. After the first bounce, it achieves a height of its original height times 3/4. So after the second bounce, whatever answer you get for your H1, it's going to be 3/4 of that. And you can visualize the scenario. It's falling like this, it's going up, it attaining the heights, falling, attaining a lower height, attaining a lower height, and so on. So this is what's happening here. And H2, if you think about it, is just 8 times 3/4 squared, which is the second bounce. Think of it. Think about it. First bounce, it comes down, it hits the ground, that is bounce 1. It goes up and it comes down, right? Bounce 2 is going to be attaining 3/4 times this expression, the first height attained after the first bounce. So basically, if you think about it, if you want to know the height after n bounces, well, that is going to be 8 times 3/4 to the power n. Why? 2 corresponding to 2, 1 corresponds to 1, and 0, no bounces, is corresponding to 3/4 to the power 0. So this is a bit different because there is context to this question. So the height, so usually when you want to solve these questions, you also want to think of context, and context matters here. So you can't use the formula blindly that we established in the previous 2 videos. So you want to be careful. So this is going to be the expression. After it hits the ground for the first bounce and goes up, so it attains 8 times 3/4. So that the subscript here is going to be the bounce number, or this hashtag bounce, which is bounce number. Okay, so that is part A. That is the expression. And B says, find the total distance that the ball travels from the first throw to the 5th impact with the ground. Well, let's think about it. The first throw, it goes up 8 meters, right? I'm on the ground, I throw it up 8 meters, and it comes down 8 meters. So I have 8 meters, 2 times 8 meters, plus, or can I write it as 2 times 8/3 to the 3/4 to the power 0? Because that's just 1, right? Plus 2 times, well, that is 0 bounces. The ball hasn't bounced. And after it travels this distance, it's going to hit the ground and it's going to bounce once. So we are on our first bounce. So this is no bounces on our... So after it travels this distance, it's going to bounce exactly once. So this is our first bounce. So let me put a dot to indicate it's gonna, after we throw it up, it goes up 8 meters, it comes down 8 meters, and then it's gonna bounce. So because it travels that distance twice, I'm multiplying it by 2. And after it does all this, it hits the ground and it's gonna bounce. So now it's gonna bounce once. And now it's gonna bounce to the next height, which is 2, and it has to come down again. So I'm multiplying by 2 again, times 8, 3/4 to the power 1, right? And then after it travels this, it's gonna bounce again, so that we are already on our second bounce, and it's gonna go on 3/4 squared, 2 times 8, 3/4 cubed, so third bounce, fourth bounce, and finally you're gonna have 2 times 8 to the power 3/4 to the power 4, and then it hits the ground for its 5th bounce, and we only want to the 5th impact, so 5 bounces. So I can factorize, I can take out 2 common and 8 common. So that is going to be 16 is common out of these terms. And inside the bracket, I have 3/4 to the power 0 plus 3/4 to the power 1 plus 3/4 squared, all the way until 3/4 to the power 4. And this is a geometric series. We know the sum. Well, 3/4, the first term, this is just 1, right? 1. 1, because 3/4 to the power 0 is just 1. 1 times r. What is r? Well, r clearly is going to be 3/4, which is 0.75. And how many terms do we have? Because we have to raise r to the power n. We have 1 term, 2 term, 3 term, 4 term, 5 terms, right? 5 terms minus 1, 0.75 minus 1. That is it. So now if you simplify, 0.75 to the power 5 minus 1 divided by 0.75 minus 1. That is 3 point something. And if I multiply by 16, my final answer I'm going to get is 48.8125 meters. So I hope you understood my explanation on why you solve this question this way. So you can't use the formula, you have to visualize the scenario out. All right, so that is question 10. So question 11 says, the second term of a geometric progression is 24. So T2 is 24. So I believe it's 48.8125, which is exactly what we got, right? All right, so the second term is 24. T3 is 12x plus 1. Find in terms of x the first term of the progression. So we know T2, we know T3. Well, we can calculate the common ratio. That is going to be T3 divided by T2, right? So it's always the nth term divided by the term before it. T3 divided by T2 should give me the common ratio. 12 times x plus 1 divided by 24. And that is just going to be x plus 1 divided by 2. And a, well, T2 is just AR. T1, the first term, is just A. So if I divide AR, which is T2, by R, then I should be getting A, right? So I know T2, that is 24. I know R now. That is just x plus 1 divided by 2 is A. And therefore, A is going to be 48 divided by x plus 1. All right. 48 divided by x plus 1. Given that the sum of the first 3 terms is 76, find the possible values of x. So I know that 48 over x plus 1, that is the first term. The second term is 24. The third term is 12x plus 1, right? All right, and it says the sum of these 3 terms is 76. Let's think about it. Well, this is an algebra question, so you can easily solve this. You can multiply by x plus 1. Why? Because x plus 1 is in the denominator. I don't like working with stuff when it's in the denominator, especially if it's variables. So the first term, which is 48 plus 1, so the x in the outside and in the denominator are going to cancel out and give me 48. Now x plus 1 times my second term, 24 times x plus 1. And finally, we are going to have 12 x plus 1 squared. And you can do this slowly and try to figure out how we got to this expression. We have 76 times x plus 1. And now these are even numbers. We can divide them by 2. So 24 plus 12x plus 1, just to have an easier equation later, is equal to 76 by 2. That is, I believe, 38 x plus 1. And again, this is divided. So 76 by 2 should be 38. And you can divide this by 2 again, actually. Plus 6x plus 1 plus 3x plus 1 squared is going to be 19x plus 1. And now we can't divide by 2 anymore. But this is much simpler than what we had in the first place. Now let's expand and simplify. So 12, we have 6x plus 1, that is my second term, plus 3 times x squared plus 2x plus 1. So that is, if I multiply by 3, I'm going to get 3x squared plus 6x plus 3 equal to 19x plus 1. Now let's collect the like terms. I have 3x squared, 6x plus 6x is 12x, plus 12 plus 1 is 13, plus 3 is 16. So that is 19x plus 1. And finally, I get 3x squared, 12x minus 16 squared, that is minus 7x, I believe. Plus 16 minus 1 is 15, that is 0. Now I can solve this quadratic equation. X is equal to 7. I'm going to do it quickly. Plus or minus the square root of 49 minus 4 times 3 times 15. So that should be actually bigger than 49. So we made a mistake, probably somewhere. 6x plus 6, not 1, because we are multiplying here. All right. So now I have 6 plus 12 is 18 plus 3 is 21. So instead of 15, it's going to be 20, I believe. Let me check if I made a mistake somewhere else. Yes, because 19 times 1 is going to give me 19 as well. So this is 19. And yeah, so this is going to be 1. 21 minus 19 is going to be 2. Sorry, I made a lot of mistakes there. All right, let me check. 18 plus 3, 21 minus 19 should be 2. All right, this should be the correct equation. And we can use the quadratic equation to solve this. It's going to be 7 plus or minus the square root of 49 minus 4ac. 4 times 3 is 12 times 2 is 24. Over 2 times 3 is 6. 7 plus or minus 5 divided by 6. So therefore, x is 2 or x is negative 1 by 3. So that should be your answer when you simplify. So I did it a bit quickly. And hopefully, when you try on your own, when you look at the explanation and then try to do it on your own, you get to the same answer. Oh, sorry, positive 1 over 3, not negative. Because 7 minus 5 is just 2, 2 over 6 is 1 over 3. So no negative values. It's 2 and 1 over 3. All right, I'm so sorry I made a lot of mistakes, but I hope you get the general idea on how to solve this question. All right, let's do question 12. T3 is 91. So AR cubed, that is my AR squared, that is my third term, is 9A. And actually, you can directly see that we can cancel out the A's here, right? So R squared is equal to 9. R is equal to plus or minus 3. All right. So we want this. We don't know whether it's plus 3 or minus 3, but let's just say it's plus or minus 3 for now. So we have used the first line. The sum of the first 4 terms is k times the first term. So how do we express sum of the first 4 terms? Well, that is just a r to the power of 4 minus 1, r minus 1, right? That is equal to k times a. And remember, a's cancel out again. So it says, find the possible values of k. So k is just r to the power of 4 minus 1 over r minus 1. Well, we just want to substitute plus and minus 3 because we have 2 different possible values of r. So if it's plus 3, then we have 80 divided by 2, which is just 40. And if it's minus 3, then we have 80 divided by minus 4, which is negative 20. So those are going to be your answers. So you just substitute the different values of r into this equation, and you get your 2 values of k. So that is 40 and negative 20. All right, this was a bit easy. All right, question 12. So we're going to do probably more questions. All right, so we're going to do 13 through 16 as well. So let me just screenshot this and put it in. So we have a lot of interesting proof questions as well coming towards the end. And hopefully I will be able to show you the proofs without making any mistakes. Fingers crossed. Probably won't happen, but we'll try. All right. So a company makes a donation to a charity each year. The value of the donation increases exponentially by 10% each year. All right. So the value of the donation in 2020 was 10,000. So in 2020, it was 10,000. And the value of the donation is increasing by 10%. So in 2021, it should have been 10,000 plus 10%, right? Of 10,000. Or another way to write this, to do this calculation, is that, well, if you think about it, right? Sorry, let me go back there. No, I can't get the value. Oh yeah, I do. All right. All right. So if I factor out the 10,000, I have 10% is 0.1, right? 10 over 100, 0.1 times 10,000. 1 plus 0.1, and that is 1.1 times 10,000. And for 2022, it's going to be, well, now it's just going to be multiplied by 1.1 again. So whatever 10,000 is, you're going to multiply it by 1.1 to increase it by 10%. So 10,000, 1.1 squared. So I'm just going to use the end numbers as reference here. 2 corresponds to 2, 1 corresponds to 1 here. So this is just 10,000 times 1.1 to the power 1. And this was 1.1 to the power 0. So the end numbers of the years are corresponding to this. That is just a helpful cue. It's not applicable to all the questions, right? If we were going like to 2030, then we wouldn't be able to use this. But since we're within 2020, so we can use this idea. Because in 2026, then the value of the donation is just going to be 10,000 times 1.1. And the number here is going to be 6. It's going to follow suit. So if you calculate it out, 10,000 times 1.1 to the power 6, that gives you the value of the donation is going to be 17,715 and 61 nildrum. 61 chetrum, I believe. I'm not sure how chetrums work, but that is your answer. All right. So that is the value of the donation. Find the total value of donation. So you want to add the terms, basically. Total value of the donations. So you had 10,000 times 1.1 to the power 0 plus 10,000, 1.1 to the power 1, all the way until 10,000, 1.1 to the power 6. And this is very easy. You can factor out the 10,000, and inside you just have 1.1 to the power 0 is just 1, plus 1.1, plus 1.1 squared, all the way until 1.1 to the power 6. And this is a geometric sequence. So you just keep 10,000, and you can use the geometric sequence formula to add these up. Well, that is just, A is just 1, so I don't need to write it out. 1.1, how many terms do we have? We have 7 terms. R is 1.1, and we have 7 terms. We have 6 terms with power ranging from 1 to 6, and then we have 1 term with the power 0. So 1.1 to the power 7 minus 1 divided by 0.1. Right? 1.1 minus 1 is just 0.1. So 10,000. So 1.1 to the power 7 minus 1 divided by 0.1 times 10,000. So if you simplify this, if you solve it in your calculator, you get 94,871.71. That is your answer. All right, so we're done with question 13. So now I believe we have 3 proof questions. All right, so we'll try to solve these, hopefully in this video. Otherwise, I'll create a part 3. So geometric progression has first term a common ratio r, and s of n. This is sum of n terms. So we want to show this expression. Let's just write down our left-hand side. Our left-hand side says we have s of 3n minus s of 2n divided by s of n. And we just want to substitute the formulas. S of 3n, let's think about it. S of 3n is just a times r to the power 3n minus 1 divided by r minus 1, right? So let's just substitute this. So we have a r to the power 3n minus 1 divided by r minus 1. That is S3n. And similarly, we can do it for S2n. R to the power 2n minus 1 divided by r minus 1. And Sn is just, again, is a r to the power n minus 1 divided by r minus 1. And now let's simplify. So we can factor a from the numerator, right? And inside the bracket, we get r to the power 3n minus 1 minus r to the power 2n minus 1. And we have a common denominator, which is r minus 1. Times, we're going to flip this fraction. R minus 1, because it's reciprocal, right? We take the reciprocal. A to the power r to the power n minus 1. So now the a's cancel out and the r minus 1's cancel out. All right. So we have r to the power 3n minus 1 minus of minus 1. Well, they are going to cancel out, right? So we have a to the power 3n, r to the power 3n minus r to the power 2n divided by r to the power n minus 1. And if you think about it, I can factor out r to the power 2n. R minus 1, r to the power n is going to be left out. Why? Remember, r to the power 2n times r to the power n is r to the power 2n plus n is equal to r to the power 3n, right? The exponents get added up when you have the same base, when you multiply these things. So now, when you factor out r to the power 2n, you get this expression. And you have r to the power n minus 1 in the denominator, which cancel out and give you r to the power 2n. And that is your right-hand side. So, all right. So we have shown that. So, fairly simple to show. So let's look at question 15. Consider the sequence. So we are given a sequence. Show that the sum of the first two n terms of the sequence is this thing. All right. So this doesn't look geometric, but let's think of it as, let's separate it out, right? So if I say 1, so let me start with 1. Then I take plus 1 over 3. So I added plus 1 over 9, plus 1 over 27, plus 1 over 81, on and on, right? And then, so I take 1 over 3, 1 over 9, 1 over 27, 1 over 81. So that is 1, 2, 3, 4, 5 terms. And then I have take 1 plus 3 plus 9 plus 27 plus 81. And on and on. So I take 1, 3, 9, 27, and 81. So that is also 1, 2, 3, 4, 5 terms. So I have 5 terms in my first bracket. I have 5 terms in my second bracket. So logically, I will have n terms here because it goes on, and n terms in my second bracket. So the sum of the two n terms is I just add these up, I add these up, and I add them together. And I'm going to get the sum of 2n. So this is a geometric series. And how do I sum it up? Well, my first term is 1. My common ratio is 1 over 3, if you can see. Right? It's 1 over 3. How many terms do I have? I have n terms. Minus 1, 1 over 3, minus 1. Plus, my first term is 1 again, so I don't need to write 1. My common ratio is 3 to the power n minus 1 over 2. So that is what this is going to simplify to. 3 minus 1 is 2. We have 3 to the power n minus 1 in the numerator. So now I want to write this term a bit more cleanly. 1, I can write it as 3 over 3. So 1 over 3 minus 3 over 3, that is actually negative 2 over 3. And I can take negative 3 to my numerator. I have negative 3 to the power minus n, right? Because 1 over 3 is just 3 to the power negative 1 times n, which is 3 to the power negative n minus 1, plus, so I have divided by 2, plus 3 over n minus 1 divided by 2. So we have a common denominator of 2. So now, if I multiply by 3 inside, we have 3 to the power negative n plus 1 minus 1 plus 3 to the power n minus 1 divided by 2. So I'm just simplifying. I multiplied by 3 minus 3, sorry. If I multiplied on the inside. Now, let's try to simplify these out. So we have 3 to the power n, if I simplify, minus 3 to the power minus n plus 1 plus 2 over 2. And I believe that is what the question asks, right? And yeah, that is what we have shown. Because it's half, I write half outside. It's the same thing, half. I have 2, I have 3 to the power. Minus n plus 1 is just 1 minus n. It's the same thing. Plus 3 to the power n. And that is, I think, exactly what the question has. So I have half, 2, 2, minus 3 to the power 1 minus n, and I have 3 to the power n. All right, so we have shown this. So you can check.